look at examples of comparing various data displays and some questions you might see for those. So this one says 20 students participated in a psychology experiment which measured their heart rates at two different situations. So situation A, situation B. What are the appropriate measures of center and variability to use? So if you notice, this data for both of these is actually very symmetric, because even you can see we've got these dots way on the end, but they both skip 5 to get to the next 2 dots, skip 5 to get to the next 4 dots. So you can see it's very symmetric. So when we have symmetric data in both situations, we're going to use the mean as our measure of center, and then we're going to use mean absolute deviation as our measure of variability. In which situation should a greater typical heart rate? So typical usually means that we're talking about an average heart rate. So we said that we wanted to find the mean for those. And since they are very symmetric, the mean is actually going to be the same as the median in this case. Median of the data, since these are both symmetric, it's going to be the same as the mean because they're perfectly symmetric. Otherwise, you would need to calculate the mean by adding up all the values and dividing by the number of them. So the mean for this one is 85, and for this one, it's between 85 and 90. So we can see that situation is higher. So situation A would be a greater typical heart rate. The next question says, which situation shows greater variability? So you can see I've drawn here that the spread for this one is larger than the spread for this one, which means the data points are further away from the mean here and a little bit closer to the mean here. So the greater variability is the ones that are further away, so that would be situation B. Example says, the depth of 2 lakes is measured at multiple spots. For the first lake, the mean depth is 45 feet with a mean absolute deviation of 8 feet. For the second lake, the mean depth is about 60 feet with a mean absolute deviation of 27 feet. Noah says the second lake is generally deeper than the first lake. Do you agree with Noah? So generally is going to mean the average. So I want to focus on those averages. So we said that the first lake average of 45, and then the second lake, which is average of 60. So I agree with Noah that the average of the second lake is larger than the average of the first lake. However, if you look at the mean absolute deviation, the greater mean absolute deviation means that there's some parts that would be shallow while there's other parts that would be deep. So we see that this one has a larger mean absolute deviation also, which means that it's not going to be as consistent. But if all we care about is generally deeper, we could say the second lake. Lynn surveyed her classmates on the number of hours they spend doing chores each week. She represented her data with a dot plot and a histogram. So this represents the same data. Lynn thinks that she could find the median, the minimum, and the maximum of the data set using both the dot plot and the histogram. Do you agree? Explain your reasoning. So I agree that in the dot plot, you could find the median, so you could work your way towards the middle. You could find the minimum number, you could find the maximum number. However, with a histogram, you just have to estimate those because we don't know if we have a number here at 8 or if we have a number in between 6 and 8 for this last one. So you'd have to estimate those. Should Lynn use the mean and the mean absolute deviation or the mean and the interquartile range to summarize her data? So if you notice that this, since these represent the same, we could look at either one, but you notice that this data is skewed to the right. So most of our data is over here. We have a little bit of data pulling our average over here to the right. So we don't want to use our average to describe it because it's being skewed by these data points over here to the right. So we want to use median and interquartile range to describe the measure of center and the spread. Plots that summarize the heights of 20 professional male athletes in basketball, football, hockey, and baseball. So we've got 4 here. Which sport has the smallest median height? So remember, the median is this line in the middle. We want the smallest, so you can see that this one's furthest to the left, so that would be baseball. Which 2 sports are the players' heights distributions most alike? So if we're looking at distributions, we want to look at like the shape of the data. So which ones are most alike? And I would say that hockey and baseball are actually the most alike because Their medians are really close together, but also their interquartile ranges are pretty similar. They're only off by about half of an inch. Which sport shows the greatest variability in players' heights? So greatest variability is going to be talking about that spread. So if we look at kind of overall, you can see basketball has the largest range. But if you just wanted to look at the middle 50%, football is a little bit bigger interquartile range than the other ones. And which sport has the least? Well, that one would be baseball because it has the smallest interquartile range, but it also has the smallest total range.